everyone, welcome back to Logical Biologist. In our previous video, we understood the basics of statistical test. Today, we are going to learn one of the most important concepts in statistics, parametric versus non-parametric methods. Many students know the names of these tests but get confused about when to use which one. By the end of the video, you will be able to choose the correct statistical test confidently, especially in the medical and biological research. I can definitely tell you. Whenever we analyze the data, statistical tests are broadly divided into two categories. The one is the parametric test and another is the non-parametric test. The biggest question is, how do you know which category to use? In which case? The answer depends entirely on the nature of the data. Let's come to the next slide. Let's first understand the parametric methods. These tests assume that your data follows a specific mathematical distribution, most commonly the normal distribution, and also known as the bell curve. If your data looks like approximately like this bell-shaped curve, then parametric tests work extremely well for this case. These tests are generally preferred when your sample size is large, means n greater than 30, and your data is continuous, such as the height, weight, blood pressure, cholesterol level, blood glucose level, etc. And because these assumptions are satisfied, parametric tests provide higher statistical power. In simple words, if your data is clean and normally distributed, then always prefer the parametric tests. Now, let's move to non-parametric methods. Unlike parametric tests, these are called the distribution-free tests because they do not assume any specific distribution. They are useful when the sample size is small. Number two, the data is skewed data or the outliers are present in the data. Number three, ranked or ordinal data. Example, pen 1 to 10. As for examples, pen scores, patient satisfaction level. Then number three, disease severity scales. Number four, questionnaire responses, etc. are the examples for the non-parametric methods. Now, talk about the head-to-head comparison between the parametric and non-parametric test, where assumption, parametric test, normal distribution, non-parametric test, none, any distribution. Data type, ratio or interval for parametric, for non-parametric, ordinal or nominal. Measures, it focuses on the parametric test mean value. And in case of non-parametric, focusing on the median value. Test power is higher than the non-parametric methods. Examples of the method, the Z-test, t-test, ANOVA, Pearson correlation, and linear regression. And in case of non-parametric methods, the examples are Mann Whitney U-test, Wilcoxon signed rank test, Krustal Wallace test, Friedman test, Spearman rank correlation test, then chi-square test. These are the methods under non-parametric methods. We will discuss one by one in the later upcoming videos. Now, understand this using real-time examples, real-time applications in the clinical research. Let's understand the parametric method with a simple example. Imagine we want to test a new blood pressure medicine. For this, we have divided the patients into two groups. The group 1 was given the new drug and the group 2 was given the placebo. Placebo means looks like the medicine but has no active ingredient, means it's a dummy medicine. And after this, we measured the blood pressure for every group, and the mean BP blood pressure was 118 by 76 mmHg for group 1, and for the group 2 the mean BP was 128 by 82 mmHg. Since blood pressure is a continuous data and both the groups having the large sample size n greater than 30, it follows the normal distribution. So group 1 and group 2 both are showing the bell-shaped graph. Then, so the best choice here is the independent t-test, which compares the mean blood pressure between these two independent groups, by which we can tell statistically that this drug is effectful for the diminishing or decreasing the blood pressure or not. Now, let's look at another example. Imagine patients are asked to rate their pain on a scale from 0 to 10 after treatment. Here the numbers don't represent exact measurements. For example, a pain score 8 is not exactly twice as painful as 4. So this is the ordinal data. It's not continuous. Also, pain score usually skewed because after treatment, most patients report low pain, while only a few report very high pain. That's why the pain scores after treatment usually skewed data. That's why we don't use the t-test here. Instead, we use the Mann-Whitney u-test as example of non-parametric methods. It combines the median pain between these two groups without assuming the normal distribution. Why does this matter? You may wonder, why is choosing the correct test so important? There are three major reasons. First, the patient safety. Using the wrong statistical test can lead to incorrect conclusions, which may ultimately affect treatment decisions. Second, precision. Non-parametric tests protect your findings when your data contains outliers or unusual observations. Third, the regulatory approval. Organizations like the FDA carefully examine whether researchers selected the correct statistical methods. So, choosing the right test is not just good statistics, it's essential for good science. Here's one important guideline every student should remember. It is called the rule of 30. According to the central limit theorem, once your sample size becomes larger than about 30, the sampling distribution begins behaving approximately like a normal distribution. Therefore, parametric tests usually become appropriate. However, if your sample size is below 30, especially when the data is not normally distributed, then non-parametric tests are generally the safer choice. Remember, this is a useful guideline, not the strict rule. Whenever possible, always check your data for normality before deciding or before doing the data analysis or any statistical test. So, what we have learned, parametric tests have higher statistical power and they are excellent when the assumptions are satisfied. On the other hand, non-parametric tests are much more flexible. They work better on the small samples, outliers, skewed distributions, and ranked or ordinal data. One simple sentence to remember is parametric tests are stronger, non parametric tests are safer. Choosing the correct test depends entirely on your data. That's all for today's video. I hope you now understand the difference between the parametric and non-parametric methods. If you found this video helpful, don't forget to like, share and subscribe to Logical Biologist. If you have any questions or doubts, feel free to ask them in the comment section. I will be happy to answer them. And don't miss our next class on the t-test, where we will cover the concept mathematics and Python coding in just 9 minutes. And stay tuned, it will coming very soon. Thank you for watching. See you in the next video.